What do you think? So quick question. How would I go about something like that? We haven't taught it yet, but anyone have any ideas? Any ideas? Go ahead. Ooh, okay. What you got?
I think you could divide 30 by 3.
Perfect.
And then times it by 2.
Cool. Okay. So we just definitely some stuff. Yeah.
Oh wait, yeah. I don't know. You multiply both sides by 3.
Okay. Okay. I like what you're saying. So hang on. I'm going to move this up here. And so let's see. There's a couple of ways to do this problem. Yeah.
Wouldn't it be the answer x equals or 2 or it equals 15 because you do 30 divided by or 45 divided by 3 and get 15, and then the 2 times 15 equals 30.
You got some numbers that are working. I don't know. I can't do it in my head, but you might be right. But hang on. Let's look at this. I'm going to look at this basically 3 ways. Can we do that? And then you got to pick the way that I feel the most comfortable, or you feel the most comfortable. So okay. So we're going to just take a look at this a couple different ways. And we haven't talked about this yet, but let's use a little critical thinking. So I think I heard someone say, hey, we could multiply both sides by 3. Those cancel. It gives me that. Is that okay so far? And that's pretty simplistic. Oh, awesome. What should we do at that point? Yeah, divide by 2. Okay? I think that's a completely legitimate way to do this problem. I think that's what you said. 45, I know you definitely said for an answer. I might not have followed the pattern. Okay, so that might be one way to do it. And again, we're just kind of sawing through this because we're going to look at this a little bit more today. Another way is what would happen if I were to divide by 2? So those cancel. So that becomes x over 3 equals 15. And then, yeah.
Why is it x over 3?
Oh, well, I could have stayed like this as well. Okay, because the 2's would have canceled. So either way, these are both equivalent forms, but that's a great question. And then at this point, I could probably say, well, let's multiply both sides by 3. Those cancel, so x equals 45. And being that we got on both of those situations, we got the same answer, so we might be onto something. Agree? What we're going to focus on a little bit today, and this isn't part of the notes, this is just kind of just warming us up a little bit, is we're going to multiply both sides by something called the reciprocal. And the reciprocal is the flipped over fraction. Reciprocal just means you flip something over. The reciprocal of like 7, 7 is the same thing as 7 over 1. The reciprocal of 7 over 1 is 1 over 7. So you can make whole numbers reciprocals just by realizing it's over 1, then you can flip it over. So the reciprocal, now notice here, I think I tagged my thing in there. So if I do that, oops, let's not do that. I thought my pencil was going to work better. If I do this, that cancels that cancels that. That gives me x. So what should I do first? Should I go 30 times 3 divided by 2? I could do that, and that's going to give me 90 over 2, which is 45. Or I could go 30 times 3 over 2, reduce this, and becomes 15. 3 times 15 is 45. Yeah, but I'm just trying to show you that there's a whole bunch of different ways that we could walk through it. And please know, what's comfortable for you is the right way for you to do it. And I'm not going to say, nope, oh, you decided to multiply by this and then divide by that. You should have done the reciprocal 2 points off. Nah, it's ridiculous. You do the way that's comfortable for you. You don't do the way that, if you're getting the same answer as me, the teacher, I think that your way is appropriate. That's how your mind works. And it's okay that your mind works that way. It's not broken. I was so fed up going through my own trials as in elementary school, middle school, and high school of, no, you have to think my way because that's the only way. We're not robots. That's silly. So if you can show a thought process that takes place, I like it. So if you would, let's go open our notes, because you said you had no questions on the homework. We were okay with the word problems as well? Or does any of those need to be talked about, looked at? Where's our last student? She went to get her money from her locker. Oh, okay. But she was definitely on the same quest as you all, right? Oh, her locker's over in at the West Middle School. She's walking. She'll be gone for about an hour. I'm just kidding. Okay, we'll make it work. All right, so are we okay on the word problems or no? Do you want me to go over any of the word problems that were on the homework? And again, we talked about the word problems when we worked them out yesterday. Was read the problem first, then maybe start jotting stuff down. Yeah.
I just want to go over
15. That's a word problem, right? All right, number 15. Let's take a look. This says, Jamie paid the rent well past the due date for the months of April, May, and June. Okay. As a result, he had been charged a total of $75 as late fee. How much did he pay his late fee each month? Okay. So one, do we understand that this person had to pay a certain amount higher because they didn't get their thing? So we had basically 3 months. We'll just call this M and M and M. It doesn't really matter what months they are because it's insignificant. But we know that basically if I were to have added these up, how much was the late fee? Okay, so M plus M plus M is 3M. So I have that. And how do I undo 3M? How do I get the 3? Yeah, go ahead. Yeah, divide each side by 3. And those cancel. So it didn't matter which month. It looks like that each month would have been a $25 late fee. Oh, I mean, that could be a practical application. Life happens. Well, yeah, it very much could be. And, there's definitely things that you think about when you read certain word problems. You might think more about the story, like how did this person get into that thing? And it becomes all kinds of different things that you could develop into it. Does it really apply to the problem? No, but does it make you normal if you're trying to think, why in the heck would, or how would this have happened, or anything like that? I mean, that's normal. That's critically thinking. That's thinking beyond what's, a word problem is kind of dorky to do in math, but it is part of the math curriculum. So we're teaching you how to think a little bit deeper, and thinking deeper as well as how did certain events happen, or what store did they go to? I heard your money was in the East building. Yep. So that's what we've done so far. So let's get our notes out for today. And if you have the notebook, great. If you don't, just grab a sheet of paper and you can write down on that. But I think the very first one starts about the same thing we had done before. Okay? Now we're going to have kind of a little game. We have the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, those are our single digits that don't start with 1, aka the counting numbers, not the whole numbers. Okay, so let's see. Let's say we are given 4, 7, and 2. So those are the numbers, 4, 7, and 2. Those are the numbers that are given to you to use. I can draw a little bit better four-sided shape than that, I think. It's not much better. Okay, so using, and this is just, I want you to think about it, play with it a little bit. You have 4, 7, and 2 to use. Plug the 4, the 7, and the 2 into any of these spots to try and get the smallest number. Try and get this. So you have to use 4, 7, and 2. The second location is squared, so whatever you plug in there will be squared. But try and get me the smallest number using just 2, 4, 7. See if you can play around with it. And then tell me what it's equal to. Does everyone understand? Got another 30 seconds, and we'll see what people came up with for some answers. Can't take me anywhere. I can't color either. Okay. Will somebody tell me what their number equaled? Not the order you put it into. What'd you equal? You got 1. Okay. Somebody have a different number? What'd you get?
Negative 1.
-1. Do you have a different number? Anyone different numbers? Yeah?
Well, 11, but I got 1 and -1.
Okay. Anybody else have any different numbers? Okay, so of those numbers up there, 1, -1, and 11, what's the smallest number? Do we all agree with that? Well, let's see how we got there. Who got -1 for an answer? What did you plug into your blanks?
I did 4 plus 2 squared minus 7.
Okay. Is that the same way that other people did it? So let's see how this works. So the 4 stays as 4. 2 squared is 4 minus 7. So I get 8 minus 7. That's 1.
I guess I switched them.
Okay. Did anyone else get a -1 for an answer, or did you just made an error? Okay. Okay. So I guess that would be the smallest. Did anyone get any smaller than 1? Like anyone get 0, or we thought it might have been negative, but that works. Huh. Let's try another one. Let's go back here. Let's try 3, 5, 7. And let's go with this squared minus this plus this equals this unknown. See if the smallest number you can possibly get. Give it about another 30 seconds, see how you came up. So I bet you, little critical thinking on this, you realize the largest number that's given to you probably should be the one squared. Agreed? Is everyone okay that 7 squared? That
For the smallest.
oh, that would have been for the biggest. Oh, boy, I'm so glad I'm amongst very smart people. So I'm going for the smallest number, so it should be the 3 that I plug in there to get the smallest number, right? Because if I plug the 7 in, I'm going to get 49. That's kind of big. If I plug 3 in there, I only get 9. If I plug 5 in there, I get 25. All right. What should go where next? Yeah. Here? Okay. And then it leaves us to 5. So let's see what that's going to come out to. I get 9 minus 7 plus 5, which is 2 plus 5, which I come up with 7. Did anybody get a smaller answer than that? Seem okay? So we're just playing around with manipulating numbers. We're reading it, and of course, you follow Stirrup's directions, you get lost all the time because What's the smallest number? I'm going to make it big. Okay. Stirrup, you didn't read directions. Oh, I know. So, am I in your way if I sit here? You probably don't like me sitting right there. Here, I'll sit. I'll put some distance between us because, you know, I'm that weird dude. All right, so let's take a look at our notes. So we talked about inverse operations, add, subtract, or inverse of each other, multiply and divide, or inverses of each other. Agreed? So let's take a look at, oh, these look like there's a little bit more than yesterday. Agree? So this turns into, yesterday we were doing basically one-step equations. Today, this is a two-step. So I'm going to still follow the same trend I did yesterday. I'm going to use my highlighter, and I'm just going to make the equal sign come straight down. And again, you're welcome to use this type of idea as a tool. I like it because I can definitely see that I have a left side and I have a right side. And we talked yesterday that when you're doing these types of problems, you want to get the variable alone. And again, the math that goes behind this is basically we said it works with your facial recognition on your phones or your fingerprint or the code you put in. Also, think about just using a key on a door lock. If the key is the inverse to the lock, it will unlock the door. If you put the wrong key in, it won't work unless you're talking about like old Jeeps and Hondas that basically you could stare at it real hard and it would turn on. Okay, just because of how the key was cut, but that was just a manufacturing problem. Theoretically, a key should work by you putting the inverse in. The inverse to how the key tumblers are would allow. Now, things have changed because we have now cars that you don't have to put a key in, but like think about that door right there. I use my key to open the door. I can't use any key. I have to use the key that's the inverse operation of it. So, you know, start thinking of it that way. So this first problem, what do you think I should do to start getting x all by itself? Because I want it to be x equals or equals x. So I want to start moving things over. What do you think? Go ahead.
13 minus 5.
Ooh, so you're deciding to subtract 5 from both sides. So that would cancel. That would cancel. 13 subtract 5 is 8. Well, and then that 2x equals 8 looks similar to a problem we might have done yesterday. Agree? So then 2 times x, I'm going to divide. So I find that x is equal to 4. So basically, 4 is the key to making it equal. Okay? And I kid you not, those subroutines, you know, on your phone and stuff, it's basically going through an if, then, else program. If the face matched up to what they had as far as the geometry. It's not the picture of you, it's the measurements between your pupils. It's probably 4 measurements on your face. If those measurements match, then open. If those measurements don't match, else reprompt. You know, please look at your phone again. I don't know what it is. I don't have the one that I can look at. But that's basically how it was taking place. So they're using some critical thinking, some literal type of equations to go through and do so we can get in and use our devices. Okay? Or you can plug in your code, or you could do your fingerprint. I mean, there's all different types of things. I feel pretty good about number 1. You feel okay about that? What about number 2? What do you think? Go ahead. Okay, I think that's a pretty good idea. So we're not even going to the variable first. We're looking at the number that's not attached to the letter. And if I do that, those cancel. So I get 4x equals, what is that, 28? And then how do I undo 4x equals 28? I think, go ahead. Yeah, because 4 times x, that's multiplication. So undo it, so I get x equals 7. So my friends, again, I'm trying to show as many steps as possible, but perhaps you might be able to do a little bit more in your head, which is fine. As long as your answer is resulting to the same and you weren't looking at your neighbor's paper to see what the answer was, You know, it always cracked me up. It's like, show work. It's like, well, it's 3 plus 4. What kind of work do you want me to show? You want me to put 3 dots and 4 dots and count them up? Yes. Oh, that's silly. Friends, talk to me. What do you think about number 3? What would be a good first step? Go ahead.
Add 6 on both sides.
I like it. Add 6 on both sides. So I get 2a equals 26. Last step to b is what? Divide by 2. Those cancel. So a is equal to 26 over 2. 13. Okay. Okay, so again, we're like, it's kind of dorky, and I know it's not the kind of puzzle you would really want to do on your own, but all it is you're undoing things to solve the puzzle. Okay, and I know it's a dorky math thing to say, but that's really what you're doing. Number 4. Where do you want to start? Someone on the far side. Anyone? Go ahead. Okay, minus 11 or subtract 11. I understand your terminology. So 9 subtract 11. I have $9 in my pocket. Something costs $11. How much do I owe? 2. So that's negative 2. Agree? 6 and m are being held together by multiplication, so I'm going to undo that by dividing, right? So that cancels. And then I can reduce. I know it's negative. What number goes into both 2 and 6? 2. 2 goes into 2 once. 2 goes into 6. 3. There we go. Oh, there's a lot of signs on number 5. Negative, negative. What should happen right here? What should happen there? Go ahead. Negatives become positive. I like that. So negative 2z plus 4 equals 18. Now, some of you might be able to do that in your head without worrying about it, but I kind of look at this saying, okay, I can see what I'm going to do now, because when I start getting more signs, heck, when someone gives me too many directions, I'm like, ooh, it doesn't make sense to me. Hang on, I have to sneeze. I feel blessed. Thanks. All right. So now, when I get down to that negative 2z minus or plus 4 equals 18, what should I go? Subtract 4. Okay. So those cancel. So I get negative 2z. 18 minus 4, I believe, is 14. Last step, shout it out. Divide by negative 2. My answer will be negative because I have 14 over negative 2. So I have a negative answer. 2 goes in 14 how many times? Yeah, baby. That's it. Ooh, last one's a little bit different because we have x over 2, so we have a little division taking place. But I think let's take care of the number part first, because that's what we're dealing with. Agree? Last step. Go ahead. Multiply by 2. All right. Those cancel. X equals negative 12. So if I take any of those answers and plug it back into the problem that they're representing, I would wind up getting a true statement. So if I plugged 4 in on number 1 for the x, I would wind up getting 13 equals 13. Well, that's a true statement. If I plug 7 in on the next one, I'd wind up getting 17 equals 17. If I plug 13 into the third one, I'd get 20 equals 20, so on and so forth. So those are like the operations to make it true. Yeah.
So if I wanted to check my answer, could I just plug it in?
Mm-hmm. And if you plug it in and you get a false statement, like you wind up getting 12 equals 18, well, we know 12 and 18 aren't the same thing, at least today. Tomorrow might be different. But, yeah, you definitely. And that's the hard thing when people say, I remember when I was in school, okay, do the work and then check your answers. That's double work. I'm not doing double work. But it is a legitimate way, and yes, it probably is the proper way, but I was kind of stubborn as a kid. I knew everything, and the older and older I got, I was amazed how much my parents actually learned. When I was 15, I thought I knew everything, and my parents were dumb. When I'm 50, it's like, wow, my parents are pretty smart. They learned a lot. They were probably always kind of somewhat intelligent. I was the dumb one. Okay, let's see. Can I move to the next screen? Or is any questions up here? We feel okay? And again, this is being recorded, so if you missed anything, you're more than welcome to go back and look at it. Okay. Ooh, we have word problems and anything else? Nope. That's it. Hey, what time are we out of here? Oh, we got time. 2 problems. We should be able to handle this. Okay. Although there's 3 problems. Oh, now we're pushing the envelope. Okay. So let's read the problem first, and then let's start figuring it out. Maybe we might have to jot some stuff down. It says 331 students went on a field trip. 6 buses were filled with 7 students. Traveled in car. Wait, 6 buses were filled, and 7 students traveled in cars. Okay. How many students were in each bus? Okay, hang on. 6 buses. So I'm going to go 6B for buses. Is that okay? And then it says 7 students also traveled in cars. I don't know if all 7 were in a car, but there was 7 students that happened to be in a car. So between my buses and my car, I had like something like that equals 331. Now hang on, this might look kind of weird, and we were kind of manipulating this strangely. So let's see. We all agree that our total students has to be 331. Hopefully for the chaperones, you have that many get out of riding back too. Nothing better than you're on a field trip going, okay, I got 329. Where do the other 2 go? Well, we got most of them. There's 2 parents waiting there going, where's my kid? They're back in California still, I guess. Oh my gosh. Huh. Huh. All right, so let's make sure we feel good. And I'm just going to highlight what we agree with. I agree with this. I agree with that so far. I like the fact that we have to equal 331. It said that there are 6 buses were filled, and it said 7 students traveled in cars. But I don't think we're like deciphering how many cars are actually going. Whether those 7 kids all drove individual cars, or they all piled in one, or they had somewhere between 1 and 7 cars. Yeah.
Well, I figured out some solid, and it's just don't count the 7.
Okay. I like what you're thinking on that. Okay. Okay. So the main thing I want, and I think you're absolutely right saying that. The main thing I want to focus on is they're saying 7 students traveled in cars. So you had 330. You got to the gates of your place that you went for your field trip, or the doors, or where you went. You're like, sweet. I have 331 field trip forms. There was a bunch of kids that got on these 6 different buses. I knew because I had a note that some of these kids were going to show up a different way. So the 7 students traveled in cars. It doesn't really, we're not worried about how many cars there were. It's just that there was 7 students that happened to have to get on our field trip in an alternative way. So I think that is a legitimate way. And I think from here we can go ahead and solve the problem. So I think from here I'd probably say let's subtract 7 from both sides. So then we're ignoring really how they got there, but they did happen to get there. And then 331 subtract 7 is... Yeah, but I like how you're thinking on that. You're trying to think through it a little bit. Hey, what's 331 subtract 7? Yeah. 320. Thank you so much for people who know how to do arithmetic, because this guy just is still trying to learn it. You realize I have sarcasm with it. You don't go home and say, my teacher doesn't even know how to do arithmetic. It's like, that's someone I told my dad last night, and he's going to call you. All right, I'm going to divide 324 divided by 6. I hope it comes out to a whole number. 54? So you got 54 students on each of the 6 buses. You have 6 buses, 54, 54, 54, 6 times. And then 7 kids got there some other way. Okay. And truly, you could have 54 students on a bus. I mean, I don't know about the regular yellow school bus, but a lot of times you would get those big charter buses. No seat quite a lot. Huh. All right. How are we doing? We're doing okay? All right. Problem number 2 says Mariah bought 7 boxes. I don't know why she bought them, but she bought them. A week later, half of her boxes were destroyed in a fire. Maria bought 7 boxes. A week later, half her boxes were destroyed in a fire. That kind of seems weird, but let's read the rest, see what it does. There are now 22 boxes left. How many did she start with? Oh. So I guess she had some boxes and then went and bought 7 more.
So did she buy the boxes after the fire?
No. I think what happened is like Maria probably had like a whole bunch of boxes. Like let's say all these desks are boxes. And then went and bought 7 more.
Okay.
And then, yeah, so Maria bought 7 boxes. A week later, half her boxes were destroyed. So she had a certain amount of boxes. She bought 7. I might be reading this wrong, but let's see if I'm right. I know that we're going to get equal 22. They said half of them were destroyed in a fire. I think.
I did 22 plus 7.
22 plus
But
7.
that was, if half of the boxes were destroyed, you need to add the 7 boxes.
Ooh, maybe.
Yeah, that's
Oh.
what I was thinking.
So
Okay.
you have to do 22 minus, or plus 7 to get 29, and then you double it to get.
Oh. Okay. Hang on. Maybe you're reading this different than me. But you guys are at a higher reading level than I am. I'm still at 2nd grade. Maria bought 7 boxes. A week later, half her boxes were destroyed in a fire. So did she buy the boxes after the fire or before? Okay, so she had a bunch of boxes here, got 7 more, fire, half are gone.
Yes.
So you have to add.
So you have to figure out how many she had before she bought the 7.
Okay. So boxes plus 7, boxes that were in the room, 7 more came, half are gone, divide by 2. And there's 22 left.
22 plus 7 equals 29, 29.
Okay, so hang on, let's be careful here. Let's be careful. Do we agree with this? What I just underlined right there.
Yeah.
So she had a certain amount of boxes. She went and bought 7 more for whatever reason. Someone dumps a match in the room, half of them go bye-bye. Goes back in the room, there's only 22 of them left. I think this is how we'd have to set it up. So I'd do this, and maybe this is what you were saying. So then I get B plus 7, because those cancel, equals 44. Subtract 7. So B equals 37. So I guess
I don't agree. That doesn't make sense. The 7 boxes are in the total. They aren't added to the total.
right.
So it's 22 plus 7?
So it's 22 plus 7 because 22 was what she had before, but the 7 boxes go into the complete total of all the boxes. So the complete total of all the boxes.
So
has to be-
you're saying this.
She bought 7 boxes, and a week later, after the boxes arrived, they all run.
Yep.
After the event. It's 44.
44?
Yeah, so 44.
You got 58? Did you get 58 by doing this way?
Yeah.
Hey, so this was a beautiful problem. And obviously, reading this grammatically, there was 2 different ways to go about it. And I kind of was misleading for a reason, because there's times where it's like, gosh, how in the heck did that happen? I would say between the 2 ways, one of the ways is what we were probably looking for, but unfortunately, it was a bunch of math teachers that helped me write this book, so now there might have been some confusion. So that's something I have to be cautious about when creating a test, realizing it could be read 2 different ways. And I think both ways is correct to think about it. even though I get two different answers. Wait a minute. You mean to tell me you're a math teacher and you might make a word problem that my neighbor might get one answer and I might get the other because we read it? Yeah. And that becomes a good valid point, saying, hey, I want to make sure that I know how to do this. So, my friends, tomorrow we have our first quiz. It's the front and the back. And it's good all the way up through, basically what I taught today. Now, I'm going to tell you that, let me get to a clear page. I would like us to do page 15 and 16, but this is due Thursday. Okay? So I'm happy to, might have a couple minutes to go over a question or two tomorrow, but tomorrow is a quiz on the Wednesday. And remember, Wednesday is the shorter periods. It's advisory. You sure can. Yeah, and this will be saved on Schoology. Pages 15 and 16, bottom right corner. My friends, get out of here. Have a great day. Take care of one another. Let me know if you need any help.
See you later.
Yep.
Thank you.
Bye, guys.
Thank you.
Yep.
Thank you.
You got it.
Bye. Thank you. Thank you.